Hello, dear friends. Now, welcome to this important discussion when we are talking about chemical kinetics. So, we shall first deal with the basics, and later on, I'll introduce you to a quiz that is going to be so engaging, so informative, so educative. Keep tuned in this discussion, and you shall enjoy. Now, we want to look at what chemical kinetics is, and we find that this is a branch of chemistry that deals with the study of rates of chemical reactions, the factors affecting these rates, and the mechanisms by which the reactions occur. And this chemical kinetics focuses mainly on understanding on how quickly reactants are transformed into products and what influences these reaction rates. So let us look at the key aspects of chemical kinetics, and one of them is reaction rate, the change in concentration of reactants or products per unit time, typically expressed as rate equal to a change in reactant over change in time, or change in products over change in time, is what we are referring to as reaction rate. So you can see the reactants have a negative, the change in reactants have a negative because obviously reactants are reducing while products are increasing during a chemical reaction. Another aspect is the rate laws, and we shall see that there are mathematical equations that describe the relationship between the reaction rate and the concentration of reactants. So when we look at this equation, this model is giving us K times the concentration of reactant A to power M and times the concentration of reactant B to power N, whereby K is the rate constant, and this depends on temperature. Then also M and N are the reaction orders with respect to reactants A and B. Now, another important aspect that we look at are the factors that influence reaction rates, and one of them is concentration of reactants. Obviously, the higher the concentration of reactants, generally increase the reaction rate. So the higher the concentration of reactants, the higher the reaction rate. And temperature, increasing temperature usually speeds up reactions by providing more energy to overcome the activation energy barrier. Remember, the activation energy is that energy that is required to break down the bonds within the atoms of reactants, and therefore making them ready to take part in the chemical reaction. So increasing temperatures will speed up the chemical reactions. So we also have catalysts. These are substances that speed up the reaction without being consumed. In other words, they don't take part in the chemical reactions. Then the surface area is also important for heterogeneous reactions. More surface area increases the reaction rate. Another aspect that you need to look at is pressure. For gases or gaseous reactions, higher pressure can lead to higher reaction rates. So, ladies and gentlemen, another aspect is the reaction mechanism. The reaction mechanism involves the step-by-step sequence of elementary reactions by which the overall chemical change occurs. It provides an insight into the molecular level details of a reaction. So, understanding this becomes very important and very key while dealing with chemical kinetics. The order of reaction is another aspect, and the sum of the exponents in the rate law that we looked at here, we are talking about, for example, here, the sum of M and N would give you the order of reaction. So for a zero order reaction, we are talking about the rate being independent of the concentration of reactants. And first order, we are looking at the rate depending linearly on the concentration of one reactant. So the second order reaction looks at rate depending on the square of the concentration of one reactant or the product of concentrations of two reactants. And then lastly, we need to talk about half-life. Half-life is the amount of time for half of the reactant to be consumed in a reaction, and it depends on the reaction order. This half-life is also related to that of radioactive elements, but here we are talking about elements that are taking part in any chemical reaction. So what is the importance of chemical kinetics, or what are the applications? So we have industrial applications, and one of them in industrial applications is that chemical kinetics help in optimizing conditions for processes like polymerization, synthesis of chemicals, and fuel consumption. In the environment, while doing environmental studies, understanding reaction rates of pollutants in the atmosphere, for example, or bodies, you need to, of course, you are applying the chemical kinetics in studying how these pollutants are affecting the environment. Therefore, it is very important. Understanding such kinds of reactions enables you to devise mechanisms on which you can design systems or design substances that are going to help you fight the harmful organisms that would otherwise harm the environment. And the next is application to biological systems. So it gives you an insight into enzyme kinetics and metabolic pathways. So it will tell you, for example, how a particular enzyme reacts with a particular, or acts or breaks down a particular food substrate. And therefore, this is very important because it helps you to understand how the enzymes are operating, so that those who are in, for example, the health or medical sector find a lot of applications there. Now, the other aspect is pharmaceuticals. And in pharmaceuticals, we are talking about designing drugs and determining their stability and shelf life. Now, I want to give you an example of, for example, in pharmacies or pharmaceuticals, there is, when you're determining the penicillin reaction, or when you are looking or studying penicillin reaction, there is an enzyme called beta lactamase. So in a process whereby penicillin is, of course, being utilized to fight against, it is an antibiotic, so it is fighting against certain bacteria. And so some bacteria come with beta lactamase, and this beta lactamase attaches itself on the beta lactam ring of penicillin, thereby inhibiting or making the utilization of that penicillin in the body, of course, useless. So that means we need to determine, for us to be able to overcome this beta lactamase, we need to study this reaction between penicillin and beta lactamase, which attaches itself on the beta lactam ring of penicillin to form a hydrolyzed product. And this hydrolyzed product is actually what is an inactive penicillin. So chemical kinetics help you to understand such kind of a reaction, and therefore maybe be in a position to design inhibitors. So that is an application in pharmaceuticals, and generally we have talked about most of the applications of chemical kinetics. Ladies and gentlemen, find me in the next video where we are going to be talking about the quiz that we have prepared. Thank you.